Hello and welcome to the second in this short series of videos about dasim. This time looking in a bit more detail about editing, adding and removing components. So let's go back to the dasim main screen again. Okay, I'll add a component, and this is done either under the Common Components menu item on the left hand side, or if I want to use one of the rarer components that we don't use so often, under the Rare Components tab. If you put your mouse on one of these icons, a little text box will come up and tell you what the component is. This, for example, is a resistor. I can grab one of those by clicking on it, and the resistor will appear on the main drawing screen here. I can drag it anywhere I want to. It's automatically floating. When I put it in the place that I want it to be, I just click and it drops onto the nearest grid points. There's an invisible grid. You can't see the grid, but you can't put the resistor just anywhere. You might be able to see that. It's jumping to the nearest grid point every time. It just makes the drawing a little bit neater. I could add a voltage source. This is a DC voltage source, which means that it works like a pump for charge. It maintains the voltage at this terminal at 1 volt above the voltage at this terminal. These grey circles with the blue dots around them are unconnected terminals. You'll almost certainly want to connect up every single terminal in your design before you start to simulate it. I showed you, I think in the first video, how to wire them up. You just click and drag away, a wire appears, don't click, just drag to the terminal you want to connect to and release the mouse button and a wire is made between those two terminals. Last time I think the circuit that we built was an LED circuit, so we started off with something like that, only we used the DC cell symbol rather than the more general DC voltage source symbol. There are actually two ways to delete a wire. The most usual way to do it is to double click on the wire. Go on. If you wanted just to rewire a wire, you sometimes want to just disconnect a wire from a terminal and move it somewhere else. And to do that, you would move the mouse to the terminal to where it goes to that sort of north, south, east, west 4 arrow shape, click, and then you can drag the wire away from the terminal becomes unconnected again. If I do that from both terminals, I end up with a wire not connected to anything, and a wire not connected to anything just disappears. Okay, editing components. This is a 1K resistor. We're probably going to want resistors with different values. If I want a different value resistor, I click on the text where it says 1K, and the text turns purple. A vertical line also appears, which I can use with the cursor arrow keys here to move it throughout that text. I can then, for example, add a 0 there, just by pressing 0, and it now reads 10K, hit Enter, return, and I now have a 10K resistor. It will always print up the value of the resistor in the standard engineering format. So for example, if I typed in 2200 and hit Enter, it will come up and say 2K2, because that is the standard engineering way of writing a 2200 ohm resistor. Means the same thing as 2.2K, but 2K2 is one less character to type, and engineers like efficiency. So we would always type 2K2 rather than 2.2K. Same thing goes with any other component. This 1 volt I could make into a 10 volt like that. I find that I usually, rather than editing the value by going and adding or taking out individual characters, I'll tend to usually hit the delete key, which removes all of the text, and then type in the value from scratch. You don't have to type in the units. The simulator knows this is a voltage source, so if I type in 10, it knows that I mean 10 volts, and it will come and print 10 volts. One of the things that often puzzles people when they start with dasim is how to remove components. And you remove components by simply dragging them off the active screen. Just drag it off the screen and it vanishes. Component gone. You can put it back again, like so. Wire it up. And my LED is lit up again. A couple of other things to mention. I'll get rid of that resistor and put in this variable resistor. Now this is a variable resistor which can take any value between 1K and 1 ohm. And I can change the value by moving the slider up and down. However, I cannot edit the value. The value is set by the position of the slider, but what I can do is edit the minimum value. Maybe I could make the minimum value 1K, and I can edit the maximum value, say 2K2, and then I can adjust the resistance anything between these two values, 1K and 2K2 in this case. Also, how to rotate components. Most of the components don't have to be placed in the orientation that they arrive at. You can rotate a component by double-clicking on the body of the component. So if I double-click on this resistor, it becomes a vertical resistor, and so on. And that works for just about any component. Like so. There are a few exceptions. One of the exceptions is the switch. This is a switch. You can put it in, but if you double click on a switch, it doesn't rotate. It just opens and closes. If I wanted to rotate a switch, then I would press the Alt key and then click on the switch. Some of these components have alternate functions, and you get to those pressing the Alt key and then clicking on it. So if I press the Alt key and click on the switch, then I get a vertical switch. Otherwise, clicking on the switch just opens and closes the switch. I can add it into my circuit, and I can now control my LED, switching it on and off. Finally, for this one, this is a fixed 12-volt voltage source. And this is the ground symbol. Standard ground symbol, 3 horizontal lines of diminishing length on top of each other. If I double click on this, it turns into 0 volts, and I can now edit the value of that. I could perhaps change that to -12, and it would become a fixed -12 volt point in the circuit. But if I edit it back to 0, then by default, it goes to this standard symbol for ground. Close the switch, and current flows again, and my LED comes on. You cannot rotate a ground symbol. You never see ground or these power symbols rotated on a real circuit diagram. Right, I think that's just about all I need to say for now. I guess I could point out one other thing, which is this component here. That is a current source. It forces, in this case, 1 milliamp of current to flow through it. You'll see maybe that the LED is just beginning to light up. with 1 milliamp going through it. But ideally, it would need about 10 milliamps going through it to light up fully. It forces a current through this. You can't go and buy a component which is a current source. You have to make one out of other components. It's like sort of a macro. It's a simplified way of thinking about various types of circuitry which have this property of maintaining the same current going through them. But it's not like a battery or a resistor that you go and just pick one out of the shelves and use. But they're very useful circuits in analysing more complicated circuits, as we'll see later. Right, I think that's about enough for this time. Next time, part 3, and we'll look at the different types of DC simulation you can do and how to get the output.